In this section of the course, we're going to talk about some of the extra topics. So we're going to talk about a few additional tidbits of useful and helpful knowledge regarding language integrated queries. So what are we going to talk about? Well, first of all, I want to show an example of applying LINQ, which kind of extends outside of the traditional data query circle. We're going to look at something that's built into the .NET Standard Libraries, the LINQ2XML implementation. As you may have guessed, it's all about working with XML file format. Then we're going to take a look at how LINQ is supported in modern development tools with a focus on ReSharper and Rider. Then we'll take a look at MoreLINQ, which is a library which improves your LINQ experience by offering you additional operators. And finally, I'd just like to mention that this entire section is a placeholder for user requested content. This means that if you write me a message or a comment underneath the course or a review asking for a particular chunk of information about LINQ that I haven't covered, then this is where it's going to appear. When LINQ came out, the technology was groundbreaking. It was emulated by almost everybody, including other programming languages, different technologies, and so on. However, uses of LINQ also appear inside the .NET framework as well. And we're not talking about core things like Entity Framework, for example. We're talking about even more data-centric things like working with XML. So in this lesson, we're going to take a look at how to work with XML using something called LINQ2XML. LINQ2XML, and this is also sometimes referred to it as XLINQ. So, what is it all about? Well, LINQ2XML gives you an object-oriented way of defining and working with XML files. Now, let me show you how an XML file can be defined using LINQ2XML. I'll just paste in a code example here. So as you may have guessed, this is in fact a document, an XML document. It has a top-level element library, and it has a bunch of music tracks underneath. So all of these types like XDocument and XElement, they come from XML LINQ, and you have to add the references if you're using LINQPad. So here in additional references, we have to go and add first of all LINQ here. So it's system.xml.linq. Let's press OK here, and we also have to have the using namespace. So here, once again, we need system.xml.linq, and now we can work with LINQ2XML. So I have this document. One of the things that LINQPad is really good at is just outputting these kinds of formats. So I can just console.writeLine. I can put in the document itself. Let's just execute, and let me show you the entire document. So we've just been using an object-oriented way of defining the following chunk of XML. As you can see, it's all nicely highlighted here and everything. So now that you have this document, you can then start working with it, and this includes both just ordinary object-oriented APIs that LINQ2XML provides, as well as using LINQ, of course, which is what it's all about. So let's see how we can use some of those. Okay, so let's start with something simple. Let's try getting all the attributes from the data that we have. Now, an attribute is one of these things, but you'll notice they are part of elements, which are in turn part of this root element. So how can we get all of those? Now, I'm going to console.writeLine, and we're going to see how we can get all the attributes. So what I can do, I can take the document, I can then take the root element, which is called root, and that is the element called library. And within that, I can go ahead and select all the elements, like so, with an elements call, and then I can do a select many and select for each of the element the attribute, and I will also flatten those, because remember, select many takes a collection, so it takes a lambda which returns a collection, but then it flattens several collections into one. So instead of having an array of arrays, you just get a single array. So here for each of the elements, I can say, please give me the attributes. This is done using the attributes function. And that's pretty much it. Let's see what we get. So in this case, what we ended up getting is an IEnumerable of X attribute. Once again, X attribute is a LINQ2XML type, which looks like this. And it's basically represented by an attribute in XML, something that looks like this. So that was a simple example. Let's do another one. This time we're going to try and find all the elements underneath the root where the attribute value is equal to 1. So this is rather easy as well. I'm going to comment out the previous code just so it doesn't distract us. Let's comment this out as well. So what I want to do is I want to take the root once again, and this time around I can get the elements, and I can find the element where the element has an attribute. So e.attribute, and this time I'm looking for an attribute with the property ID having the value equal to 1, like so. So if I execute this, well, we have a bit of a problem here. That should be elements instead of element. Let's do this again, and we now have an IEnumerable of a single X element which has this value. In actual fact, instead of where, I could have put a single in here because I know that I'm expecting just a single element, and here instead of having an IEnumerable, which you have to enumerate, I just have the value that I was looking for. Alright, so let me show you a final example. Now, something that HTML developers specifically would know is that it's possible to use XPath. Now, XPath is a way of searching for particular elements inside your XML collection using a kind of domain-specific language. It's rather simple, and you can use it using Xlink as well. So let me show you something else. Let's suppose that I want to find all the music tracks where the genre is rap. So how do I do it? Well, I can certainly do it using ordinary link. Just go through each X element and use a where to find the attribute and check the attribute, but I can also use this XPath. So here I can say doc.xpath select element, and here I can use the XPath notation. So I can do // I'm looking for a track where the genre is equal to rap, like so. And when I execute this, here is my track ID. Let me actually comment out the above example and run this again. So here is the track where the genre is rap. So this gets me just a single element, but if I put an S here at the end and run this again, then I get every single track which is of type rap. So now I get 2 tracks because 2 tracks have the rap genre. Now, one thing to watch out for is that XPath is case sensitive, so if you put rap with a small r, you're not going to get any results. If you are using either JetBrains ReSharper or JetBrains Rider, then you already have plenty of link-related functionality that's built into your IDE. And I want to show you some of the really good examples of where the IDE can help you working with links specifically. So first of all, let me make a class called human here. Human, so I'll have, let's have public string name, public int age. And then let's suppose that we have the following code. So for example, let's suppose you have a function where you process humans in some way. So you have a function called void process. You take an IEnumerable of these humans, human like so. It's called people. Now let's suppose that you do the following. First of all, you try to get all the children. So you say var kids equals people.where p.age is less than 13, for example, and then you do something else. Let's say you want to calculate the number of teenagers, so you say number of teens equals people.where p goes to p.age is greater than or equal to 13 and p.age is less than or equal to 19, and you do a count. Now there are lots of problems with this code, and you can see that Rider in this case underlines all of this code and tells you that it's really terrible code, and I've deliberately written this. First of all, as you can see, you can really replace the call to where followed by count to just a call to count, because remember, count has an overload which takes a predicate, which is precisely what the whole of this happens to be. So what we can do here is we can press Alt-Enter and we can replace the function where followed by count with just count. So let's do that. But even so, even though this code is much better now, we can still improve it, because you'll notice that we're enumerating the people parameter more than once. And once again, Rider tells us that it's a possible multiple enumeration of IEnumerable. What we can do here is we can press Alt-Enter and we can enumerate it to an array or a list. For example, in this case, we simply introduce a variable, let's call it PPL, and this is how you do it. So you can see that there is plenty of smart code that's happening here. It's not just, give me a to list. It's a lot smarter than that, because what ReSharper tries to do, or in this case Rider, which is almost the same thing, is it tries to check whether or not people is already an iList, because if it's already an iList, there is no point in actually doing a to list. You can simply do a cast. You can simply say people as iList, but if it fails, if the cast fails, it returns a null, and this is why we use the null coalescing operator. So if it's null, then we do a proper to list. We actually materialize the collection to a list, but if we don't have to do it, then we simply do a cast. So this is some very efficient code that's being offered by Rider here. Let me show you another example, a more complicated example. Let's suppose you want to find all the teenagers who are called Adam. A very strange query, but let's do it anyway. So you have an IEnumerable returning function. Let's call it IEnumerable. Well, it's going to return IEnumerable human. It's going to be called get teenagers named Adam, and once again it takes an IEnumerable of human. So we take the people, and then let's suppose that you decide not to use link. You decide to use a for loop. Now, how would you do this in a for loop? Now, you would have to introduce some sort of list. So you would have a list called result, a new list of human, and then you would have to populate this list. So you would go through each of the people you have. So for each var p in people, and then inside people, you would say, well, if p.age is greater than or equal to 13 and p.age is less than or equal to 19, if p.name is equal to Adam, then you can add it to the result. So you can say result.add p, and then you can return result. Now, what Rider and ReSharper let you do is they let you convert this entire construct into a link invocation. You simply press Alt-Enter on the for each and you choose the convert into link expression. So let's press return here, and what you can see is that all of these checks, all of these things that we've done have been converted into a link sequence. So we say people.where with the specified teenage restriction, then where with the specified name restriction to list. So this is absolutely wonderful in this particular case. I have to warn you though that on the internet you're going to see lots of examples where people automatically converting their loops into link end up with really crazy code, really complicated and completely unreadable code. So this functionality is sometimes useful. In this case, it certainly is, but in other cases, it can be quite detrimental to readability and to maintainability of your code, because it can spawn really bizarre link expressions. So use it carefully and keep in mind that you can always press Ctrl-Z to actually undo the whole thing and go back to the for each if that's easier to understand for you. Okay, so final example. Something completely different. Let's suppose that you have, let's say, a string like var x, for example, equals, and let's suppose you have a bunch of XML in it. So you have foo, and then you have bar, and then you have closing foo tag. Now, what ReSharper can do is it can actually detect the fact that the string contains XML, and it can use the link to XML APIs to redefine that string. So you'll see I've deliberately put a var in here, because now what I can do is I can press Alt-Enter here and I can use link to XML, and in this case the XML gets replaced by the appropriate object-oriented constructs. And this functionality is quite sophisticated. If you have a sophisticated complicated chunk of XML, it will turn it into an object-oriented structure, which is really useful. Of course, now you can get rid of toString because you might just want to keep it as an X element. So this functionality is also part of Rider's and ReSharper's support for language integrated query. In this case, it's specifically for link to XML. And you're going to see lots of other examples of link support as you experiment with Rider or ReSharper. There's lots of functionality in there, but this overview hopefully gives you an indication of the fact that your IDE takes care of you, and when you're using link, it tries to find certain ways of optimizing things and making life a little bit better. MoreLink is a really useful extension to LINQ. It's simply a collection of different operators which you can also use on your sequences. Now this library is available in NuGet, so if you open up NuGet you got to search for MoreLink, just install that and you've got everything that you need. So MoreLink actually has lots of different operations, and I want to show you just a few of those to get your appreciation for the kind of things that this library offers. So let's do a short demo. Let me put a constructor in here. So we'll have SVM, and I'll do MoreLink demo from here. Now let's start with the batch operator. Now a really useful operator, by the way, because what you can do with the batch operator is you can group several elements into a batch to be processed. So instead of processing elements one by one, you can wait until you gather a certain amount and then process those. So let's do a small batch demo here. Now what I'm going to do is I'm going to generate a sequence, as always. Let's generate a sequence of some numbers, for example. So I'll have, well, let's have 100 numbers. So var numbers equals enumerable dot range from 1 to 100. So we got 100 numbers. And now what I can do is I can take these numbers, I can take the sequence, but I can take it 10 elements at a time instead of just one element at a time. So I can say something like for each var batch in numbers.batch, and here the argument is how many elements you want in the actual size of the batch. So I want batches of 10 elements. So for each of those, I'm getting batch, which is a collection of 10 elements. I can then go ahead and, for example, right line the fact that I got a batch, and then I can process each of the elements. So for each var I in batch, so for each of the elements in this batch that I got, I can, for example, output this once again with a console write to the command line. So I can output the element followed by a tab maybe, and let's put an end line at the end of it all. So if I now execute this, you can see that my data set has been divided into several batches. So I get a batch and I get a collection of 10 elements. I get another batch and I get another collection of 10 elements. So the new element, if I had 101st element, wouldn't be processed until I got another 10 elements to work with. So this is batch. It's a really useful tool, and you see lots of Stack Overflow questions about this. Let's take a look at interleaving. So let's have an interleave demo. There we go. Now interleaving is very simple. It's all about taking several collections and kind of mixing them together. So for example, let's suppose that we have two collections of random numbers, but they're going to be different. So I'll have a random number generator, and then we're going to have two collections. We'll have whole numbers, and whole numbers are just going to be done using enumerable.range 1 to 10, and then I'll do a select, or where we don't care about the value, and we just do a ran.next 10. So we generate a random number from 0 to 9 and turn it into a double as well. Now, a different sequence might be some floating point numbers, so we'll have some fractional numbers, fract numbers, and this is going to be enumerable.range 1 to 10 once again, and then I'll do a different select. So this time round, I'm going to say rand.next double. There we go. Okay, so we have two sequences. One contains whole numbers, the other contains fraction numbers. Now what we can do is we can interleave them, which means that you take from one, you take from the other, you take from one, you take from the other, until you completely run out of data. So I can write a for each var d in whole numbers dot interleave with fractional numbers. There we go, and let's see what we actually get. So I'm going to output the number, console write the number itself. I'll also output a tab character once again. So console write \t, and I'll put an end line at the end of it all. Right line like so. Now let's see what we actually get. All right, so as you can see, the output is a whole number, a non-whole number, a whole number, a fractional number, whole number, fractional number, and so on and so forth. So a very simple idea, but once again, this isn't something that's included in LINQ, so you get this as a kind of extra benefit with this library. Now let's look at permutations, a very common problem actually. So let's do perm demo. Permutations is all about finding every single permutation of all the elements inside a collection. Now there's a difference between permutations and combinations, because combinations you can pick as many elements out of the original collection as you want. Permutation is all about swapping their position. So for example, let's suppose I have a bunch of letters in a word. So I have var letters equals, let's choose the word draw, and turn it to a char array. Now what I want is I want to find all the combinations of those 4 letters in different words. So I can say for each var item in letters dot permutations, like so. Let me just permutations, there we go. And then for each of those I can just write line by reconstituting the sequence of letters that I have into a new word. So I'll make a new string and I'll take item.toArray. So what happening here is that letters is an array of characters. To char array should be obvious, but let me just reiterate this. So it's a char array, and then we take all the permutations of all the elements inside the char array and we make a new word out of each by invoking the string constructor. Let's take a look at what we get. So as you can see here in the output, we get draw, DRWA, and every single other combination of those 4 letters. Okay, so let's take a look at a final example, and the final example is going to be about splitting this sequence. So let's do a split demo. Okay, so the idea is that just like with a string that can be split on a particular character, you can also take a sequence and you can split it into subsequences on a particular value. So for example, once again, let's do a random number generator. So I'll do new random, and then I'll make a sequence of numbers. So I'll have enumerable.range. Let's have 100 this time, and then I'm going to select. So I'm going to make a bunch of random numbers from 0 to 9. So rand.next with a value of 10. And let's suppose I want to split the sequence anytime I encounter a 5. So I have the sequence of 100 numbers, and I'm going to slice it into subsequences anytime when I see a 5 in that sequence. And obviously the 5 itself gets thrown out. It's the separator. It's the part that we don't care about. So here, just like with string.split, you say var split equals numbers.split, and then you specify what you're actually splitting on. Now you can see lots of different overloads to this, but the simplest is where you just specify the value. So I'm going to split on the number 5, and then I can go through each of the groups. Since I've split a large sequence into subsequences, each one of these is a group. So I can say for each var group in split, and then inside this I can write line something. So for example, I can say that I have a certain number of elements in the group. So I can say group.count, for example, elements, colon, and then I can output the actual elements. So let's do that. Now for this, we need to do string.join with a comma separator maybe, and here we just specify the group itself as an enumerable. Now you can see there's a bit of highlighting here saying I'm enumerating this multiple times. It is in fact correct. I shouldn't be doing this. I should be turning group into an array or a list before actually doing this, but that's okay. That's fine. Let's just execute this. Let's see what we get. Hooray! So as you can see, we've split the sequence of 100 numbers into several different groups with 4 elements, 1 element, 8 elements, and so on. And the number 5 is nowhere to be seen because it happens to be our separator. Now, there are lots more operators in MoreLink, and I suggest that you go to the webpage, which is on the GitHub. That's where you can find the documentation as well as a list of every single operator that MoreLink actually supports. As you can see here, there are actually quite a few of those. Now let's try to summarize what we've learned in this entire course. First of all, we talked about the idea that LINQ essentially specifies a set of standard query operators, and we saw that there are different implementations of LINQ depending on the technology that you're using. So if you're working with in-memory objects, then you're working with LINQ to objects, and the interface you're using is called IEnumerable, and you're working with a large set of extension methods on an IEnumerable, and all of those extension methods, or most of them at least, take func parameters. We also looked at LINQ to entities, and indeed we talked about LINQ to other database and object relational mappers, and we mentioned that in this particular case the interface that's being used is iQueryable, and the extensions, instead of just taking func, they take expression of func. Now, we also mentioned that there are other varieties of LINQ, such as, for example, LINQ to XML. And then we looked at the asynchronous support in the entity framework. So in addition to making ordinary queries in the current thread, you can also make asynchronous queries in a separate thread. We also looked at parallel LINQ, which kind of expands this idea because it supports query parallelization. So that's essentially the idea that you can run your query on multiple threads, thereby leveraging the multi-core architectures. We also looked at developer tools and how they help you use LINQ effectively. And finally, we looked at an external library, MoreLink, which expands the base LINQ capabilities. So with all that said, I'd like to thank you for checking out this course. If it's not too much trouble, then please leave a rating and review underneath this course. I also welcome any kind of feedback, and I try to respond to any feedback that you leave. If you need to get in touch with me directly, then please use this Twitter handle, dnestorg. And finally, I'd like to wish you the best of luck in applying language integrated query in your .NET development practices.